In this video, I'll demonstrate the configurable state model library object of machine builder libraries. Configurable state model instruction provides a common command and status interface for users to develop a state-based application. Here is an example of state-based application. As shown here, the unit module is currently in the running state. When commanded to stop, it will enter the stopping state, and once the stopping state is complete, it will enter the idle state. The configurable state model instruction provides a flexible control mechanism where the states and their transitions can be configured to build an application framework. The user will only need to program the action logic for each state. This helps in faster and easy application development. The state transition relations can be configured from HMI or using Logix Designer without any code modification. This allows easy customization of application. The instruction can be applied for units, equipment modules, and in complex control modules. The object has ownership options for program and operator. These ownership options can also be configured. Exception modes like out of service, maintenance, and override means no additional code is required to manage exception conditions. Controller wake-up action is configurable to start from last valid state and step or start from the initial state. This is useful in application where the unit is allowed to continue from last state after a power recycle. The functionality to allow a state sequence to progress to a pre-programmed pause point and continue with the receipt of continue command is useful in application where operator actions are required in a process. The instruction can be commanded logically to resume to a particular state and step. The state configuration is validated by the object to avoid any illegal operations. The instruction provides command and status information to facilitate interfacing with supervisory control and sequence control. The instruction can be configured for 31 states. For the demo, I have a stock supply chest application here. The application code is divided into two equipment modules, one controlling the pump and related devices, and another controlling the tank and related devices. The unit module is used to coordinate the tank and pump equipment. Each equipment module has a configurable state model instruction with an automation sequence associated with each state. The unit module also has a configurable state model instruction with automation sequence commanding the equipment modules in each state. As shown here in the unit module, the configurable state model instruction is in the main routine with jump subroutine instruction associated with each state routine. The state routine contains respective sequence that will be executed once the state is requested programmatically or by operator from HMI. The interlock routine contains permissive interlock instruction monitoring the interlock conditions. When any of the interlock condition fails, the state model instruction will be commanded to execute the configured interlock state. A similar implementation of state model, permissive, and state routines is done in each of the equipment modules. When instantiating the configurable state model library in ACM, the user has the choice to only instantiate the state model instruction or the implementation with state routine and permissive interlock instruction. Apart from configurable state model instruction, the application also have I/O module and digital and analog channel instructions. These instructions help in managing the analog and digital I/Os. The valves and agitator motor are controlled by D2SD and D3SD instructions. These instructions have faceplate that can be configured to have personality as per the device application. The stock pump is controlled using the motor VSD instruction. The tank level, dilution, and flow control are controlled using the native PID instruction. The faceplate for PID instruction is from the process library. In the HMI, these are the navigation objects for unit and equipment state model faceplate. The navigation object displays the description, ownership mode as programmer operator, and the current state. This is the navigation button for permissive interlock instruction. I'll open the state model faceplate. This is the home tab. On the top is the ownership control. The ownership can be changed from HMI or programmatically. The ownership can also be locked from HMI or program to prevent ownership change. Current state, step, and the respective time is displayed here. The states can be commanded from the command buttons. Each state can be configured to have a command button or not. The state buttons will be enabled as per the transition configuration. Each state has a permissive input that must be set programmatically to allow the transition to that state. The permissive logic for each state can be connected to these bits to prevent state from executing if the permissive condition is not met. As shown here, the control state has a permissive condition of tank level. Since the tank is currently empty, the permissive is not available. This button is for operator to acknowledge the state model to continue when the state model is in a sequence wait condition. In the settings tab, these are the buttons to enable maintenance ownership. When the module is in maintenance control, the program state requests and state permissive conditions are ignored. The state transition control is given to maintenance engineer for troubleshooting purpose. As you can see here, all the commanded state buttons are enabled now, irrespective of the transition condition. The permissive condition is also removed, thus the control state can be executed. When in out of service mode, the module is not available for use and no transitions are performed. As you can see, all the command buttons are now disabled. When the module is in operation, no configuration changes are allowed. To edit the configuration, the module must be first put in out of service and then enter configuration has to be selected as yes. The reinitialize button is to execute the initialize state. This button is enabled while in maintenance mode. In the configuration tab, this is the pulse duration for fault reset output. The fault reset output can be used to reset the devices. In configuration tab, the parameters can be modified if enter configuration in settings tab is set as yes. In this parameter, the user can set the wake up action of the controller. When selected as init, the instruction will execute initialization state on first scan. If last state is selected, then the instruction will execute the last state and step that was being executed before controller rebooted. This parameter is set when configuration changes are done in program mode of controller or in offline ACD file. When set as yes, the state model instruction will copy the configuration from configuration parameters on first scan. The action is only done once and parameter is reverted to no after copying. This is the local message file name in FTView Studio. The local message contains the step description to be displayed on the Home tab. In page 2, user can select the ownership model. Option to have program, operator, and log function can be selected here. This button launches the configuration faceplate. In first page, the user can do the basic state settings. This button is to enable the state. If the state has a command button, then this checkbox has to be enabled. Select this checkbox if resume point capture has to be done. This is the state complete target, which means the next state to be executed after the current state is complete. If no transition is selected, the module will remain in the current state until a new state is requested by program or operator. The state name and the button label can be modified in the Logix Designer. In page 2, select the first state to be executed after initialization. Also, the state to be executed if interlock condition fails, and the state to be executed when input faulted is set. In page 3, select the valid state transition targets. As shown here, the resetting state can transition to idle state or interlocked state. Returning to state model faceplate. The diagnostic tab gives an overview of configuration errors and listing of last 10 active states. The help tab provides description of parameters and also the command buttons. In this application, the unit module is under operator ownership, as the operator will command the required states from faceplate. When executing any state in unit module, the equipment modules are put in program ownership and programmatically commanded by the unit module. Since the tank is currently empty, the control state permissive is not available. First, I will command to run the filling state. Now the unit module is in filling state. Since this is to only fill the tank to a set point, the stock chest module has executed autostart and is in running state. Since no action is required from the stock pump is in idle state. Once the set point is reached, the stock chest will be commanded to stop by the unit module. In the filling state routine, you can see in step 300, the stock pump is commanded to enter program ownership. Once program ownership is achieved, the stock pump is commanded to run the flushing state. Once the flushing state is complete and stock pump is in idle state, the logic moves to the next step. Here the stock chest is put under program ownership. It is commanded to run start manual state. Once the stock chest is in start manual state, the logic moves to next step. Here the tank level is monitored to the set point. Once the tank level is reached, the stock chest is commanded to execute stopping state. Once the stock chest enters the idle state after completing the stopping, the sequence is completed. At the end of the sequence, both stock pump and stock chest are put back into operator ownership. Since now the control permissive is available, I can command to run the control state. Now you can notice both stock chest and stock pump are being commanded for auto state. I'll command the unit to stop now. Next, I'll demonstrate the sequence wait and continue feature. This is used when operator confirmation is required to continue to next step in a state. In the draining state of a unit module, I have a step where operator confirmation is required. I'll open the draining state logic. Here in step 601 of draining state routine, the P command sequence wait bit is latched to command a wait sequence. First, we will execute the draining state. Now you can see the state model is at 601 step and is in sequence wait. The continue button is enabled to indicate it's expecting an operator confirmation. Once the operator presses the continue button, the sequence will continue. Next, I'll demonstrate the step done command. The instruction can be commanded programmatically to move to next step using the step done command. This is done to manually move the model forward without the normal completion conditions. First, I'll run the filling state. In the filling state, the state model is at step 302 and waiting for the tank level to reach the set point. This is the P command step done. Once I latch the step done parameter, the step will be skipped and filling state will be completed. You can notice the stock chest has moved to idle state before the set point is reached. The next feature I'll demonstrate is the resume. The state model instruction can be commanded programmatically to resume a state and step using resume command. When a state is selected for resume enable, the state number and step number are updated in val resume state and val resume parameters. In this application, the filling state is allowed to resume if due to any fault the unit enters interlock state and later fault is cleared. The resume logic checks if current state is in interlock state, override conditions are cleared, and module was executing filling state. Once the conditions are matched, the P command resume is latched. I'll demonstrate the resume logic. First, I'll start the filling state. Now the filling is running. I'll fail an interlock condition for the unit to enter the interlock state. Now the unit has entered the interlock state. You can also check the interlock fail reason in the interlock faceplate. Now I'll revert back the interlock condition. You can see the unit resumed back to filling state. In this section, I'll demonstrate how to instantiate configurable state model object in Application Code Manager. The ACM already has machine library registered. You need to download the libraries from Rockwell Automation Product Compatibility and Download Center page. I have already created a project, added a controller and a display. To add, right-click on the task and select Add New. In the filter, enter Config State. In Configurable State Model, there are two implement libraries. The first one is to only implement the state model instruction. The second one is to implement the state model instruction along with state routines and interlock routine. Select the first one and click Next. I'll enter the object instance name as stock supply chest. Enter the description. The program name, routine name and tag name can be modified as required. I'll change the program name as unit stock supply chest. These are the state numbers for interlock state and fault state. We will come back to the parameter later. Enter the instrument ID and the instrument short description. Select the display where the navigation object has to be placed. Click Next. In this tab, enter the state configuration. To add a state, right-click and click Add New. Enter the state name. I'll enter as resetting. Enter a state number. Enter the button label. If no command button is required, then leave it as no command. Enter the next state number. If resume enable is desired, then select resume enable. Select the transition condition for the states. To add another state, right-click and click Add New. Since idle is desired to be a static state, the next state number can be left as 0. Since from resetting I can enter to idle state or interlock state, I will select both. From idle state, I can enter to filling state or interlock state. From filling, I can enter to stopping state or interlock state. From stopping, I can enter to idle state or interlock state. Click Next. Click Auto Create to create the link libraries. We'll go back to the parameter and enter the interlock and fault state. Click Finish. Next, we will add the Configurable State Model generic module library object. Go to link libraries. Since we have already added the configurable state model, select the link to existing instance. Click Finish. Next, we have to add the permissive interlock library object. Select Create New Instance. Enter the object instance name. Select the task and program. Configure the permissive interlock object for the inputs with interlock. Click Next. Create the link libraries. Click Finish. Now we have both the configurable state machine and the permissive interlock library object. Click Finish. As you can see, the interlock routine and the state routines are now added. To understand further about generating the code and display, watch the ACM Workflow Basics video series. For more information, download Machine Builder libraries from Rockwell Automation website. Thanks for watching the video.